Really nice pronunciation, thanks. Yeah, so I'm Laura, and I'm here to tell you about boosting test coverage for microservices. Here you can see the agenda, and please stay present, as the image says, even though it's after lunch session. So I know it's hard, but struggle with me. So first I will introduce to you myself and the open source project I work in. Then I will tell you a little bit about my views on automated testing and how do we do automated testing in our project. Then we'll move on to test coverage, what it is, why you should care, and more importantly, how do we utilize test coverage data in our project. And then we will take a closer look into our solution that helped us to gather even more test coverage data in our continuous integration pipeline for our application testing. So we'll take a closer look of that then. So here is my professional timeline. You can see some of the technologies I have worked with and the companies I have worked in. And I like to call myself as Jane of all trades, master of none. So I love to hassle with many kinds of things and learn new tech as they come along and when projects have the needs for them. And so I'm not a testing specialist per se. That's just one of the things I hassle with. And Go is something that I have been using since 2016. And nowadays, it's the primary backend language for me. I work in OP Financial Group, which is the largest bank and insurance company in Finland. And yeah, my name is Finnish, so Vuorenoja is Finnish, and that's why it's a bit difficult to pronounce it. But anyways, specifically in the company, I work in OP Lab, which is our innovation unit. So my duties is to research and experiment with new technologies. And this is the technology, the new technology I'm specifically interested in. So verifiable data exchange is something that helps us to make internet even more better. So it's an enabler for decentralized and self-sovereign identity, and this technology is something that I have researched for over 4 years now. I think it will actually revolutionize the way we build web services so that they become more reliable, more secure, and more privacy-preserving. So the basic idea is that entities, such as persons, such as me and you, or organizations, or even things that have an identity, they will become the owners of their own identity data instead of storing that in some central location. I won't go too deep into this technology. I just want to give you an overview that you know with what kind of things I am working with. So like I said, we have these different entities that has an agent that is a piece of software that can handle their digital identity. And this agent is capable of doing these complex cryptography things and also handling these different kind of symmetric asynchronous communication protocols between different entities so that you can exchange your identity data and in the end build trust between these entities in the internet. So this kind of decentralized domain differs from the previous projects that I have worked previously. So if you think about like a traditional web service kind of project where you have the end user and the web service, here there are multiple moving parts. So each transaction have multiple entities, multiple parties participating in them. You have these asynchronous complex protocols, And these, also these asynchronous notifications play a big role in this scenario. Findy Agency is the open source project I work in, as we call it, and it is the result of this research work that we have been doing the past 4 years. We describe it as a multi-tenant decentralized identity agency. So the purpose for Findy Agency is to provide for applications and also for individuals these different kind of identity agent services so that you don't have to write themselves to your applications in order to participate in these verified data exchange flows. So agency hosts the identity agent for you, and you can use the agency API to handle your identity agent. We use microservice architecture. We have various styles, different kind of clients, and in addition, we have divided the code into multiple different repositories. Yet, at the same time, we have a really small team, and we do rapid experimentation. So we use this agency as a platform for these experiments, and we want to keep the agency code, even though it's like innovation lab code, and we are not certain if it ever will reach production, but we want to keep it like as stable as possible so that it's always ready for the next experiment. And when you consider that, okay, you have this decentralized domain, you have this microservice architecture, this multiple different kind of repositories and so forth, there are a lot of these moving parts. So we have noticed that automated testing is the one thing that keeps us sane. And therefore, I have come to share you the joy of automated testing today, to give you some tips how you can gain big results with small teams and not break things. So let's start by defining what is automated testing, and if you have a code repository that has a test script, and you might even have in the README really good instructions for running those tests, is that automated testing? Well, I think not. I think that automated tests are only those tests that are run in the continuous integration system. So if you have fancy scripts lying around in your repository, but nobody runs them, it's not automated testing. It's just another form of manual testing. So the idea is that whenever you have code changes, the continuous integration system runs these tests, and if the tests are not passing, they are not merged to main. Probably familiar approach the most of you. So I like to think this automated testing as an extra team member. And this team member's duty is to fight against regression. And if regression is not a familiar term to you, it was not for me when I first encountered it. It means just like that we end up breaking some already working functionality in the software when we are introducing new changes. So that's the simple explanation for regression. So automated testing is our tireless night against regression. This night warns us if something is going to break when we are doing those changes. So when we are creating the pull requests, it will alert us if there are problems. And this night, this automated testing set, it's not a static one. So it's evolving all the time. Whenever you introduce new changes, you put in the best possible tests for that feature because you are the expert on that feature. You put tests in, and when they get merged to the main, they become the part of this night against regression, this test set. Also, a good approach is to do so that whenever you encounter an issue, a bug, when you deliver a fix for a bug, you always include also a test for this bug when you deliver the fix. So you won't be ending up breaking the same stuff all over again. Okay, so what kind of automated tests do we have? Let's start with the simple. So, of course, the unit tests is the basis of all automated testing. And that's the automated testing we know most of, and I think that most of us are doing this already. So they are run with the Go unit testing tooling, and then you can implement these test cases using the standard library testing package. And they are really great if you don't have any external dependencies, and you don't need to fake any external logic. So here is an example of that kind of a happy path. It's a copy-paste from the standard library math package, where there's the test for the ABS function. So you just give input parameter, get the output, and you can compare the result that was it like expected. There's no need for any external stuff here, and the testing is really simple. So if you are a Go standard library math package developer, good for you and congratulations. That's probably all you need. But what about the rest of us mortals? We who develop web servers, for instance. You are starting to have different kind of dependencies in your code. So, for instance, you may write or read from the file system. You may send data or fetch data via network. You might store some data to an external database. Your logic might be dependent on time passing by. Or you use that complex third-party API, such as some cryptography API, perhaps. So what happens here? In the same time, you want to keep your tests simple and modular, and you want to make sure that you test only the code that you have written. Like somebody said yesterday when I was talking about this, why would you test all over again some HTTP module functionality if they have already their own tests in that project? And therefore, you start writing a bunch of simulation code. So you may write these mocks, stubs, fakes, pies. They all work a little bit differently, but they all have the same purpose, so to simulate your external dependencies. And that's most of the time fine. There's no trouble in writing this kind of simulation code, but to be honest, sometimes it takes a lot of effort. And for me, writing these mocks is not my favorite thing to do. So I would probably code the logic for the new module than write the mocking code for the tests. Also, some scenarios are really hard to mock. So it will take a really lot of effort, or they are even impossible to mock. And then there is also one thing to keep in mind when doing this simulation code, that who will then test the actual software? Because your end product probably won't be used by that is using your simulated code, but it's using the actual external dependency. Is it the end user that tests your end product? I hope not. Well, therefore, I'm going to tell you about a way that you can complement these unit tests. And, well, a dear child has many names. I call them in this presentation application tests, but you might call them integration tests or end-to-end tests. And this is, like I said, something that complements the unit tests. So, and when I talk about this application tests, I mean that it's not run with the unit testing tooling and not the test cases are not written with the standard library testing package, but we run the software with its real external dependencies, and we don't use the unit testing tooling. So these application tests can help you in the cases where the unit tests fail you. So for instance, when you are testing interoperability between your internal components or services, or to the outside world, or some other logic that is difficult to simulate, sometimes it's easier to test with these application tests. So what kind of tests we do in the Findi agency project then? So of course, like many of you, our primary way of doing testing is unit tests. And we have written our share of the simulation code and the testing helpers. And also have like some quite extensive integration tests implemented with the unit testing tooling. But to complement that test set, we have written a bunch of these application tests. And typically, we run them in our CI pipeline. So we use GitHub Actions, as it's free for open source projects. So what happens in the application tests typically is that we launch the agency environment with Docker Compose. So the different services are running in their dedicated containers. And then we execute the test scripts against this environment. What was like pretty surprising for me when I started to use GitHub Actions is that the support for running these Docker environments in the pipeline is quite good nowadays. So there is not so many mysterious problems that I've been having with at least like 5 years ago and so forth. So these kinds of test setups are quite easy to write nowadays. We have 3 kinds of application tests at the moment. So we are using the graphical user interface to execute the test through the browser. We have our agency CLI tool that can be used to manipulate the agents in the cloud. So that has been a really handy tool to write these tests. And in addition, we have also this kind of test harness that we use to test agency interoperability between different software agents, so that we can test that our agent is speaking the correct protocol in the correct phase and so forth. So what these application tests helps us is to do that, like I said, test interoperability to the outside world between our internal services, validate that the notifications flow from service to another in a correct way. And also the bonus here is that we are actually using these same container images for our deployment. So when we are starting up this environment with the Docker Compose tool, we are actually testing at the same time that the container is also working, that we are going to deploy to the cloud. So that, for instance, that all of the settings are working correctly and so forth. So it gives us like really good additional feedback in addition to the unit tests. Okay, what about test coverage then? So traditionally, we measure test coverage for unit tests. And it's quite simple to produce this kind of test coverage data with the code tooling. So you just add the cover flag to your code test command, and you get a bunch of coverage data out, and then you can convert it to a format or another, for instance, to a HTML format that is then easy to view. Here is an example of that kind of visualization. I'm not sure if you see the colors, but there are green lines, there are yellow lines, and red lines. And green lines means that when the start connection protocol function is run in the tests, these green lines are executed during the test. Then the yellow means that that line is executed partially, and the red lines are not executed at all. And what this means is that, for instance, in the row 103, we execute the defer call, but we don't actually execute the error that is given as an argument to this catch function. So that's why it's partially executed, and the error case is not executed at all in this testing. So this kind of visualization is really good for you when you are doing locally development. So what I do usually, I don't do TDD because I usually tend to figure out the requirements when I'm already doing the coding. So in my case, it's so that I usually write the first version, then I start thinking about the tests, and during writing the test, I run this tool locally to see that, okay, am I missing something when I'm writing the tests? Is my test covering all of the things that I'm about to test? It's also a good way to improve your code quality. So many times when you are checking this visualization, you see that, okay, I'm doing something really stupid here. I need to refactor this thing. I need to make this more testable, or so forth. So in a sense, it also is a tool that improves. You can, like, yourself make a code review to your own code when using these visualizations. So I recommend to try it out if you haven't already, to take a look how does your code look like when you run these coverage visualizations. Okay, and then of course you can calculate the total coverage percentage for your code files. So you can calculate the coverage percentage. Usually means that what is the total test coverage for your code lines, and you can get for your project a nice, like, round number if you are doing good. But I wouldn't recommend to see or watch too carefully that number, because the high percentage doesn't equal good test quality. You can have really poor testing and really good coverage. Maybe you don't even check the return value in the test, but your code lines are still covered. So this coverage percentage doesn't tell you maybe anything. But the most important thing is to remember that it's not meaningful to outsiders. So I have heard that some companies use this data as their manager's bonus criteria, and don't do that. So it will just lead you to write poor quality tests. So the coverage percentage is meaningful only to the project developers. So it determines how well the tests cover the various aspects of the software, and it helps you to find your blind spots in your tests. It's not meaningful to outsiders. One thing that this coverage percentage is good for is to, when you are using this kind of automated monitoring to monitor your test coverage, that does it increase or decrease? So we actually are using this kind of monitor in our continuous integration pipeline, and this monitor alerts us if a pull request is going to change our coverage so that it will drop the coverage. We are using this service called codegov.io, as it's free for open source projects, and it works so that whenever you create a new pull request, you run your tests in the CI with this cover flag on, you get the coverage data, and you convert it to a format that this analysis tool can then understand. The analysis tool will make the analysis in their own server, and then they will provide us feedback if the coverage was increased or decreased. So they will actually post a comment in our pull request to say that what happened to the coverage. In this case, the coverage has remained the same, so there's no impact, and we can go on merging this pull request to the main. But if there would be a drop, there would be some red flag, and we won't be able to merge the pull request and so forth. So I think that we have gotten quite nice experience using this tool, especially for people like me who are really like always in a hurry, and when they figure out some solution for an issue or a new feature that they get completed, they are so in a rush and so like thrilled of themselves that they just want to merge everything to the main and be fast and so forth, and then they forget to add the tests. So this tool will nag you every time that when you forgot to add the tests. So it will keep your night against regression, the test set, like in a good shape automatically. You don't have to worry about it yourself, that am I going to drop the coverage or not. Also, this tool has helped us to find some random issue when we've had some changes in the test environment, and partially our code hasn't been, our test hasn't been run, so it has like helped us with some random issues as well. Okay, so unit tests, it's quite straightforward thing. You just add some tests in some flags to the unit test command and integrate the monitor into the CI pipeline and enjoy the ride. But what about the application tests? So you might want to have the similar kind of feedback for those tests as well. And nowadays, it's possible. So I think it has been possible also before, but now Go has made it really easy for us. So with Go 1.20 release, we had a new flag in the Go build command that helps us to instrument our binaries so that we can get the coverage data also from these programs. So Go 1.20 supports collecting code coverage profiles for programs, application, and integration tests as opposed to just unit tests. So we can instrument our binary executables, and when we are running the tests, we can produce the coverage data. And this new feature inspired us to refactor our CI pipeline for the application test. And let's look what I did in that refactoring process. But first, just a basic overview how this new feature works. So we have this new cover flag in the Go build command, and when you are using this cover flag, you will get the instrumented binary. Before you run the binary, you define environment variable called go_cover_dir that points to the folder where the result data, the coverage data, is then generated after the test run. Then you run the binary and run your tests, of course. And when this program stops, you can get the coverage data in that go_cover_dir path, and you can do what you wish for that. So handle it similarly as with the unit tests. So in this case, for instance, I am converting this data to text format. But how about those Docker images? Like I said, we are doing our application testing in the Docker images, so we needed to modify our Docker files as well. We have two stages in our Docker file. So the first one is the build stage, and the second one is the run stage. So in the build stage, I, of course, needed to add the new cover flag to the build command. So I added this new Docker build argument called go_build_args to the Docker file that the image builder can use to give any flags now to the build command. So now if you are building this image and you want to produce the instrumented binary, you just give the -cover in this go_build_args argument. Then in the run stage, we need the new environment variable, which is called the go_cover_dir. And here I just hard-coded it into the container root, where is this folder coverage. So after the executable stops, it will generate the coverage data into this path. So I wanted to utilize this new way of gathering coverage data in one of our application tests. So as we have this microservice architecture, we have one test set that is common for all of our services. So it's like executing the most important features for the agent functionality. And this test will run the most important features for each service for these test cases. So it works as so that whichever service is under test, that image is built for that repository head and replaced into the Docker Compose environment. Otherwise, the other images are used, pulled from the container registry, and then the test script is run against that kind of environment where you have one modified service and other ones pulled from the registry. So what changes needed to be done in this testing? Of course, build the service image with this instrumented binary, like we saw in the previous slide that we had this Docker file. So use this new flag and so forth. Then the application testing, just like before, launches the test environment with the Docker Compose tool. It will run the test set. So basically, it's a bunch of these test scripts that are run through the browser, the graphical user interface tests, and also some tests run with the CLI tool. And then lastly, we get the coverage files in the result directory. And we can then convert and send the files to the analysis tool. And yeah. So there's an example of the Docker Compose YML file here. So when this testing test phase is booting up the test environment, it will use like the other services from the registry, but then in this case we want to test this Vuort service. So we are building this Vuort image from the Vuort repository sources, and here we are using the new Go build arcs, which is where we place this dash cover flag, and also we are mapping the folder, the coverage folder, to our local folder so that we can access the coverage data after the container has stopped. Yeah, and this actually, the whole thing, this booting up this environment and running these tests, I have written a dedicated GitHub action for that. So that's this GitHub action job is now in the Vuort repository CI definition. So first there is happening the test action, and after that, when the tests are executed, we get the hand of the new of the coverage data of the tests run, and what we do is that we convert the data to the TXT format in this GitHub action job, and then we actually store that in the GitHub Actions artifacts because we then send this data in one step together with the unit test coverage data to the analysis tool. So I think here is an example for that. So actually, we have here in the Vuort repository, we have two testing jobs, one for the unit test that is called test, one for the application test that is called end-to-end. Both of these jobs generate us a coverage data file that is stored here in the artifacts, and those files are then sent in the upload coverage step to the analysis tool that is able then to merge and analyze these files together so that we can get the whole coverage analysis in one step back. Okay, and what happened? So like said, I used this approach in one of our microservices, that was this Vuort service, and there we had an increase almost 5 percentage units. And why was that? Well, that was because we had so much untested code there that was now executed with these application tests. So for instance, we had a bunch of logic in the main function that was not tested at all in the unit tests. We had some logic for these WebSocket and gRPC listeners that are sometimes hard also to mimic or to simulate in the unit tests, and also some other code that is hard to simulate. So that's why we had an increase there. I integrated this change also to our other services, and some services even have had a drop in the coverage, because this testing now introduced new files that were missing altogether unit tests. So we found out that okay, we have some files that don't have any testing existing, but except for now that we are doing the application tests for them. So it revealed us some dead code and some untested code that we now have to take care of at some point. Yeah, so overall, this new logic improved our understanding how well the tests cover our code base. And just as a curiosity, this is the way, if you log into this CodeCov service, you can also get these nice-looking graphs and so forth, but I don't really use this. So I just use this GitHub action integration and never bothered to watch these. But they are there if you are interested. So overall, this change was quite straightforward and even fun to implement to our continuous integration pipeline. The biggest hurdle for me was learn how to shut down the services gracefully. So the coverage data is lost if the program does not exit normally. And what does that mean in a web service? So you have to implement this graceful shutdown. And that wasn't actually a tricky part, because the internet is full of good instructions how to do that. And I got some help from my colleague. But the tricky part was to learn how to ensure that the Docker actually passes this SIG-term signal to the container so that it knows to shut down gracefully. So there was some banging head against the wall when I tried to figure that one out. So if you try to do something similar, just ensure that Docker is passing the signal to the server process if you are figuring out that why isn't the coverage data appearing where it should. Okay, so my takeaways today: use nights to fight regression. So run your tests in the CI for every change you do, and keep your night in good shape. And what helps you to do this is to monitor your code coverage with the automated tooling. So utilize the tooling. Complement unit tests with application tests. So make sure that the end user is not the first one to test your code with the real dependencies and real external stuff. And remember that if you are writing these application tests, it's also now possible to measure this code coverage even for those. And last, maybe not the the easiest one to implement, is write open source, because you get these great tools for free. But most importantly, it will make you a better developer, and your overall life quality will improve also. Thanks.